Okay, final exam, tests from last year that the kids took, 2, C, and D. Um, the C question is, you're given two particles. You got a particle P and you got a particle Q moving around, right? And it looks like P is given to you with just some data points, which you got to use some kind of trapezoidal sum to approximate the area underneath the curve to approximate the displacement. Okay, which we don't need that for the C question, but we need then. Well, we're going to need that B question later on. The C question is you have another particle that travels by some function here. So the Q particle. The Q particle has a velocity of 45 square root t cosine 0.063 t squared. And then if you graph it, you get something like that. And then well, you actually get this graph here, something like that, right? And then find the time during which the velocity is at least 60 miles an hour. So from here to here is when it's, this is V, and V is above 60 here. I put that in Y2. And so I put this in Y1. And then, so what I want is this area there, right? I think let's find the distance traveled. Now, keep in mind the distance traveled is technically the absolute value of this. So remember, the distance traveled is technically the absolute value of this V of Q. But since it's already positive in this whole area, you don't really need the absolute value. That may have caused some distraction for some of you when you were looking at the answer key, because the answer key keeps that there. Now you do need these A and B points though. And it turns out that if you use the intersection function, and you're going to want to store these pretty accurately, right? 1.866181, and the other one is 3.519174. And then when you do that integral, when you put those points in for A and B, you get your answer, which is 106.109. You could truncate and make it 106.108. Now, the B question, the D question, this was the C question. The D question was, I lost it here. I set the paper down in a funky way so I can't see it. Hold on. Okay, so the D question here, at time 0, particle Q is at negative 90, okay. Use the result from B to approximate the distance between the particles. Okay, so what we need to do is we need to find out where each particle is. Okay, where is the particle? In B, so we have particle P and we have particle Q. We want to figure out exactly where they are. We want their position. We want the position of P and we want the position of Q. We know that when P started, it was at the origin. Okay. Now I want to do this not the way I normally would. Yeah, let's just not do it that way. So let's do this right. We want to find P of at what time do we want to do this? At 2.8, right? P of 2.8 minus P of 0 is going to be the integral from 0 to 2. I'm going to do it the way I would do it. I was kind of doing it the way the AP exam was doing it. And then Q of 2.8 minus Q of 0 is going to be the integral from 0 to 2.8 of the velocity of Q. This is the velocity of P, right? Sorry, the notation is kind of funky here. So this we did in B. We calculated that, so we know so P of 2.8, and they tell us it starts at the origin, so this is minus 0. And then we actually calculated that. That turns out in the B question to be 40.75. So the position of particle P is at 40.75. We figured that out. Now it's, you know, it's we don't have to worry about moving it at all. Q is we're trying to figure out where Q is. Now we're told at Q of 0 though it was at negative 90. So I'm gonna have to put plus 90. Minusing is 90 there. And then the integral here, you're gonna have to put that since this is sitting in y1, just do the integral from 0 to 2.8 of that. And if you do that integral, you end up with 135.93765. 135.93765. Let me say this again. So the integral from 0 to 2.8 is the position at 2.8 minus the position at 0. The integral from 0 to 2.8 is the position of Q minus the position at 2.8 minus the position of Q at 0. This is just fundamental theorem of calculus. This position is 0, and this position was negative 90. This, I didn't use a calculator, I used trapezoidal sums to approximate. This is not exact, of course, it's approximation. This I did use, I put that in Y1, and I did use the calculator to calculate this integral between 0 and 2.8. So now keep in mind that I have to move that 90 over. So P is at 40.75, Q is at what, 45.9765. And so how far apart are they? You just subtract them. So subtract them. You want the absolute value, 5.188. 5.188, I think, if you subtract them. So you do want to subtract the two of them and then absolute value it if you do P minus Q. Make sure you guys do. So kind of looking at a number line here. If you're looking kind of at a number line, P would be here at 40.75 and Q would be here at 45.9765, and the distance between the two of them is 5.188 or 5.187.